Now let's look at oxidation number in this video and multiple practice problem at the end of this video will be done. Now when you have an atom, a molecule or an ion, the apparent charge you have on any of these is what we call the oxidation number. Let's take a look. If I have this, if I have Na and I have Na plus, and I have Al and I have Al3 plus, you observe that the apparent charge I'm having here is 0, the apparent charge I'm having here is +1, the apparent charge I'm having here is 0, the apparent charge I'm having here is +3, which happens to be their what? Oxidation number. That is the apparent charge you have what? On atom or ion or a molecule. Now, let's see. Our major concern in this topic is how to calculate the oxidation number of an atom in a compound or an atom in a radical. When we talk about a radical, it represents groups of atoms bearing a charge, whether positive or negative charge. For example, this is an example of a radical. 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 Groups of atoms that are carrying a charge. So whenever we are asked to calculate the oxidation number of any atom in all these compound or ion or radical, how do we do it? Now take note of rules to calculate oxidation numbers. Rules. Now the first rule is that when you have an element, when you have an atom in free state, the oxidation number of such atom is equal to 0. That is the first rule. For example, if I'm having Na, Ca, Fe, Cl, F, and so on like that, all these, the oxidation number of all these atoms is equal to what? Is equal to 0 because they are in free state. Okay, they are not carrying any charge. Now, the second one is this. For charged monoatomic ion, for monoatomic ion, for example, what are monoatomic ion? If I have Fe2 plus, Cu plus, okay, let me use anyone, Cu2 plus, Cu plus, if I have F minus, Cl minus, if you look at all this, the oxidation number respectively, this one, because the charge is 2, the oxidation number is what? +2. Because the charge is +2, this one is also +2, this is +1, this is -1, this is -1. So whenever you have a charged monoatomic ion, the oxidation number is equal to the charge on it. The next one is, take note of this. If you have group 1 elements, are you there? For example, if you have group 1 element like, okay, let me include, I have hydrogen, lithium, if I have sodium, potassium, and calcium. All these are group 1 elements, and the oxidation number of this group 1 element is equal to +1. Also, if you look at group 2 elements, okay, so we have, for example, we have beryllium, magnesium, we have calcium. All these, the oxidation number is equal to what? +2. They are group 2 elements. Oh, no, this calcium is not here. Oh, sorry, it's not there. This is not here. This is a group 2 element. Sorry about that. So these are group 1 elements. So I'll stop at the side. So hydrogen, lithium, sodium, potassium, this is +1. This one is what? Is +2. Also for group 3 elements, if I have boron, aluminium. So all these, we have what? We have the oxidation number to be what? +3 because they are group 3 elements. So whenever you see any of these, take note of the oxidation number. Now, group 4 elements could vary. Like carbon, it could vary depending on the type of compound you are dealing with. So for carbon, it varies, which is in group 4. But the one in group 5, just take note that what? The one for sodium is, for nitrogen is equals to -3. Take note of that, for nitrogen -3. Okay, so if I look at group 6 elements, for oxygen, take it to what? -2. Of course, it varies. It varies. Also, For group 7 elements majorly like chlorine, bromine, iodine, are you there, fluorine, all these, the addition number is equals to what? Is equals to -1, just like you have it here. So these are what you have here. Now for oxygen, take note of something. Look at for oxygen. If you calculate the addition number of oxygen and it gives you -2, so that is a normal oxide or a basic oxide. So you have a normal oxide or a what? Or a basic oxide. You have a basic what? Basic oxide. Okay? When the addition number is what? -2. Now, if the addition number is what? Is -1, take note that that compound is a peroxide. Is a peroxide. Whenever the addition number of oxygen is -1, that compound is a peroxide. Also, if the addition number is equals to -1/2 for oxygen, take note that that compound is what? A higher oxide or a higher or superoxide. A higher or superoxide. And lastly, if it is -1/3, you are having ozonide. So that is it. Now, for hydrogen, look at for hydrogen. For hydrogen, the addition number could be +1 or -1. Normally, in the compounds of hydrogen, it's always +1, but when will the oxidation number of hydrogen be -1? It is when hydrogen is combined with metals. For example, in hydrides like NaH, you can see a metal and hydrogen. In this compound, the oxidation number of hydrogen will be what? -1. Also, look at this. Look at this compound, lithium tetrahydroaluminate 3. Look at this. A metal, and you're having hydrogen. Take note here, the addition number will be what? -1. So if hydrogen is combining with a metal throughout, the addition number of hydrogen here will be equal to what? -1. But with non-metals like HCl, H2SO4, so it will be what? +1. So pen down this rule as I erase it and we start solving. Now, we already have the rules in our jotter already. So looking at this, I'll look at this compound H2SO4. You have to calculate the oxidation number of sulfur in this compound. That is the question. So how do we get the oxidation number of sulfur in this compound? Take note, this is a compound, it has no charge. The sum of the oxidation number of each of the atoms you have here must be equal to the charge on the compound. What am I saying? Look at what I'm having here. I have 2 times oxidation number of hydrogen plus oxidation number of sulfur plus 4 times oxidation number of oxygen. You can see after adding the oxidation number of each of the atoms you have here, it must be equal to 0. Why is it equal to 0? Because this compound has no charge. So remember, hydrogen is +1. We don't know the one of sulfur, so I can call it X. Oxygen -2 equal to 0. We'll pen it down already. Now, this is +2. I have plus X. This is what? -8 equal to 0. So I have X. 2 minus 8 is -6 equal to 0. So X is equal to what? +6. Always include the charge. So the oxidation number of sulfur in this compound is +6. What of if I have Na2CO3? You have to calculate the oxidation number of this underlying atom, carbon. How do we do it? Remember, 2 times oxidation number of sodium plus oxidation number of carbon plus 3 times oxidation number of oxygen must be equal to 0. Why is it equal to 0? The compound has no charge. So you have 2 plus 1 plus this is what I'm calculating, that's X, plus 3 times -2 equals 0. So this is +2 plus X minus 6 equals 0. So I have X. 2 minus 6 is what? -4 equals 0. So S is equal to what? +4. The next question. If I have question like this, Na2H10 S2O8, you have to calculate the oxidation number of sulfur in this compound. How do I do it? Very easy. Oxidation number of sodium, 2 times oxidation number of sodium plus 10 times oxidation number of hydrogen plus 2 times oxidation number of sulfur plus 8 times oxidation number of oxygen must be equal to 0. So the sodium is plus 1, Ne plus 1 is in group 1, hydrogen also plus 1, sulfur, they ask us to calculate it, I don't know. So I'll say X, and remember I have 2 of sulfur here, so I have 2X. Then 8 times the number of oxygen was minus 2 equal to 0. So plus 2 plus 10 plus 2x minus 16 equal to 0. So here I have 2x. Now 2 plus 10, that's 12. 12 minus 16, that is what? Minus 4 equal to 0. So 2x will be equal to plus 4. Divide both sides by 2, x will be equal to plus 2. Okay, let's look at another question. What of if I have CaH2 S2, I want to get the oxidation number of sulfur in this compound. What do we do? Now, let's see. Remember that calcium is a group 2 element. Firstly, I'll just say oxidation number of calcium plus 2 times oxidation number of hydrogen plus 2 times oxidation number of sulfur must be equal to 0. So this is what plus 2 times plus 1 plus 2 times, sulfur is what they asked me to calculate, so I'll just say 2x equals 0. So remember, this one will give me 2. 2 plus 2 is 4. Then plus 2x equals 0. 2x equal minus 4. Then what will I have here? Divide both sides by 2, s equal minus 2. That is that for this. So let's look at another one. If I have this Na2C2O4, you have to calculate the oxidation number of carbon here. Okay, let's see. So for carbon, firstly I'll say 2 times oxidation number of sodium plus 2 times oxidation number of carbon plus 4 times oxidation number of what? Of oxygen. 4 times oxidation number of oxygen equal to what? 0. So I have 2 plus 1 plus 2x, then plus 4 times minus 2 equals 0. This is plus 2. This is minus 8 equals 0. 2 minus 8 will give me minus 6. 2x equal plus 6. When minus 6 come here, plus 6, then if you divide both sides by 2, s equal to what? Plus 4 as required. S equals to plus 3. Okay, that's it. Now, that's that for that on compounds. So that's that to calculate the oxidation number. Okay. All right. Let's look at examples like this. S2O82 minus. You have to get the oxidation number of sulfur in this compound. So what do? Very simple. So we are still going to say 2 times oxidation number of sulfur plus 8 times oxidation number of oxygen will be equal to what? Will I say equal to 0? No. It will be equal to what? The charge you have here. The charge you have here is what? Minus 2. So I'll say equal to what? Minus 2. So 2x, I'm asked to calculate the oxidation number of sulfur plus 8 times minus 2 for oxygen equal the minus 2. So 2s equal minus 16 and this minus 2. So minus 2 plus 16. So I have 2x equal to minus 2 plus 16 will give me what? Plus what? Plus 14. So if you divide both sides by 2, x will be equal to what? Plus 7. Look at this also. BrO3 minus. Calculate the oxidation number of bromine here. So what do? We don't know this, so I'll say oxidation number of bromine plus 3 times oxidation number of oxygen will be equal to what? The charge here is minus 1. So I don't know this, so it's x. Oxygen minus 2 equal minus 1. So when minus 6 comes here, it becomes plus 6. So x will be equal to plus 5. So the next one, if I have LO2 plus. And you have to calculate the oxidation number of chlorine here. Let's see. So this is X. Okay, let me first write the equation. Oxidation number of chlorine plus 2 times oxidation number of oxygen must be equal to plus 1. So this is what I don't know. It is X. This oxygen is minus 2, then equal plus 1. So from here, what do I have? X minus 4 equal plus 1. S equal 1 plus 4. And S equal to what? Plus 5. So the oxidation number of chlorine in this compound is plus 5. Alright, that is it. So lastly, if I have P2O7 4 minus, and I'm asked to get the oxidation number of phosphorus in this compound. So let's go on. 2 times oxidation number of phosphorus, I have 2 atoms of phosphorus, plus 7 times oxidation number of oxygen equal minus 4. So I don't know this, 2x plus 7 minus 2 equal minus 4. So from here, I have 2x minus 14 equal minus 4. 2s equal minus 4 plus 14. 2s equal to what? Plus 10. If I divide both sides by 2, x equal to what? Plus 5. And that's that about that. Now, lastly, I want to explain something. Look at this compound. Look at this compound. Okay. And look at this compound. Briefly, let's calculate the oxidation number of oxygen in this compound. We are asked to calculate. The oxidation number of oxygen have to be calculated here, here, and here. So let's go on. What do we have here? You see that oxidation number of hydrogen here 2. Then for oxygen 2 equal to 0. Here 2 plus 1. I don't know the one of oxygen. I'm asked to calculate the one of oxygen, so I'll just say 2x equals 0. So whenever they're asking me to calculate the oxidation number of any atom, you will just replace that as x or y or anything you want. So plus 2 plus 2x equals 0. 2x equal minus 2. And if I divide both sides by 2, x is equal to minus 1. What did you observe? The oxidation number of oxygen in this compound is minus 1. So oxidation number of oxygen in this compound is minus 1. And here, let's take notes. Oxidation number of potassium plus 2 times oxidation number of oxygen equal to 0. Potassium group 1 plus 1. I don't know the one of oxygen equals 0. So 2s equal minus 1. When plus 1 comes to the other side, you have minus 1. If I divide both sides by 2, s will be equal to what? Minus 1 over 2. This is what I have. So here, the oxidation number of oxygen is equal to what? Minus 1 over 2. Let's look at this one. Oxidation number of Na plus 3 times oxidation number of oxygen equal to 0. So this is plus 1. And I don't know the one of oxygen, so I'll just say x equals 0. 3s equal minus 1. If I divide both sides by 3, s is equals to what? Minus 1 over 3. Now, oxidation number of oxygen here is equals to minus 1 over 3. What do you observe? Remember, any compound where the oxidation number of oxygen is minus 1, that compound is a peroxide. If it is minus 1 over 2, is a super or higher oxide. And if it is minus 1 over 3, is what? Ozonide. So it affects the name we call it. It affects the common name we call all this. That's why we call this hydrogen peroxide, because the type of ion that is there is a peroxide ion. But forget about that. It is called hydrogen peroxide. So I can say simply because the oxidation number of oxygen in the compound is minus 1. It makes it a peroxide. Here I will say potassium superoxide. It's a superoxide just because the oxidation number of oxygen gave me minus 1 over 2. So here I will say sodium ozonide. Why am I saying sodium? Why am I not saying sodium oxide? Why am I not saying sodium or any other name? It is ozonide because the oxidation number of oxygen here is minus 1 over 3. That's that. Okay, let's look at this. Calculate the oxidation number of hydrogen in this compound. Remember that this compound, I brought it so as to remind us, this compound contains metals. Sorry, we have to get the oxidation number of what? Aluminium. Take note, this compound contains metals. So the oxidation number of hydrogen will be -1. So let's go. Oxidation number of lithium plus oxidation number of aluminium plus 4 times oxidation number of hydrogen must be equal to 0. So lithium is in group 1 plus 1. Aluminium, they asked me to calculate, so I'll just say X. Even if you know it before, just calculate it because at times it might vary depending on the compound. Here, since we are combining with metals only, so hydrogen will not be +1, it will be -1. Please take note of it. So I have 1 plus X minus 4 equals 0. So X, 1 minus 4 is what? -3 equals 0. So S is equals to what? +3. S is equals to +3. So that's that about that. Lastly, if you look at questions like this, if I ask to calculate the oxidation number of iron in this compound, how do we do it? Now, take note of something that if you see if you see a molecule in a compound, the oxidation of that molecule is equal to 0. For example, see, if you see a molecule like ammonia in a compound, the oxidation number of ammonia is what? 0. Like NO, the oxidation number is what? 0. But if you see CN, cyanide is -1 because the ion is like this, CN minus. But this one don't come in form of ion, so CN minus. So anywhere you see the CN minus, CN, the oxidation number is what? -1. So let's go. Let's calculate this. So I'll say 2 times oxidation number of sodium plus oxidation number of iron plus 5 times oxidation number of cyanide plus oxidation number of what? NO, then equal to 0. Don't say N and O. NO, they are together. So I have 2 plus 1 plus, I don't know this one, X plus 5, Cn minus 1 plus this is 0, equal to 0. 2 plus X minus 5 equal to 0. 2 minus 5 will give me what? -3 equals 0. Then X is equals to what? +3. So it's ion 3 that is inside our compound. Nice. If I have Ni CN4 minus, so what do we have here? Oxidation number of this, that will be asked to calculate. So oxidation number of nickel plus 4 times oxidation number of Cn, will it be equal to 0? No, it will be equal to -2. So this one, I don't know, it is X. This one, remember, cyanide, that's -1 equal -2. So X minus 4 equal -2. S equal -2 plus 4, and S is equals to what? +2. That's it. So the task I'll be giving us, and comment your answer in the, put your answer in the comment section for me to know you are following and you are participating actively. So calculate the oxidation number of copper in this compound. Cu NH34 2 plus, and also the oxidation number of copper. And the second one, oxidation number of, see this compound NH3 6. So oxidation number of this MO. So that's that. So thanks for watching.